Hi, let's continue with the preparation for the quiz. And the second part, and the final part, is pertaining to the variable type equations that we need to know and be able to use. So what I have here is the question from the textbook, and it's question 1C. No, it's not a question, it's problem. So the questions at the ends of chapters are divided into exercises and problems. So this is problem 1C.2. And it describes a situation where you have argon gas at a pressure of 100 atmospheres and a temperature, and a temperature of 273 Kelvin. They give you the second virial coefficient, minus 21.7 cubic centimeters per mole, or if you like, mils per mole. And the third virial coefficient, C, is equal to 1200 centimeters to the 6. So that would be in mils. What would it be? If centimeter cubed is milliliters, centimeters to the 6 is milliliters squared. So if you want to change those units, go ahead. And that's per mole squared, or mole to the minus 2. Okay, and we're asked to find the value of the compression factor Z, and then asked to find the molar volume. The question instructs you, and this is really important, to assume the perfect gas equation for your first estimate of molar volume in the calculation of Z. So what are they actually talking about? First of all, you have to decide which one of the two virial type equations is at play here. Which one is relevant? How do you make that decision? You look at the coefficients that you are given, and I think that you should be able to clearly determine that it's the virial type equation in which these coefficients are multipliers of molar volume, or specifically reciprocal molar volume, and not pressure. Those are your two choices, okay? Molar volume or pressure. And the reason why I rule out pressure right away is because no way will this multiplied by pressure cancel all units. So this is the virial type equation that we're using in this question. Now, what is the concept behind this equation, so that there's the least amount of memorization and you get it, you understand it, and so there's the least amount to just simply memorize, because that's not helpful. All right, we know that PVM over RT, well, it's equal to 1 for a perfect gas. We've been doing that since high school. Maybe not molar volume, it was written as PV over nRT is equal to 1. So what we say now is a little bit different. PVM over RT is equal to the compression factor, and Z is equal to 1 for a perfect gas, and it ends there. But for a real gas, we have to tweak that number 1 a little bit. It's going to end up being a little more or a little less than 1, because either the dominant forces are repulsive or attractive, respectively. That makes it a little greater than 1 or a little less than 1. Okay, so we've decided that this is the virial equation. The virial type equation is the one that uses molar volume. Just as a note, if B prime and C prime were given, and those are coefficients of pressure, then this would look a little bit differently. It's still PVM over RT is equal to Z. Of course, it's equal to 1 plus, and that's where the tweaking comes in. If it were the other equation that was being used here, that would be B prime times pressure plus C prime times pressure squared. And we say plus ... because in theory this is sort of like a series that goes on, except that the little bit that you're tweaking with each successive term is smaller and smaller, and really doesn't affect your answer because you're not carrying those that number of significant figures. So we always stop after 2. Right, so this is what we are after, and so we can look at the equation sort of from here, right. So we have Z is equal to 1 plus this over this plus this over the square. So we'll plug in the B and we plug in the C, but the question is, what do we have for molar volume? Because we're just given pressure and temperature. And it comes back to that statement in the question where it says, use PV-nRT, your perfect gas equation of state, to estimate the molar volume for the second and third terms. So watch our terminology. This whole thing is the second term, and this whole thing is the third term. B is the second virial coefficient. This is the third virial coefficient, but this is the second term, and that's the third term. Okay, so that's what we do. We use PVM equal to RT to estimate our molar volume. Okay, so if PVM is equal to RT, then VM, the molar volume, is equal to RT over pressure. So I take this RT over pressure and I substitute it for molar volume, and in here I'm going to put it in and square it. And then I'll put in my numbers. So let me just uncover the rest of this and we'll go through it, okay, as a solution. Okay, so 1 plus, so my B value was a minus 21.7 centimeter cube per mole, and now I have RT over P on the bottom. The value for R is 0.08206 liter atmosphere per mole K, and that's really dictating to you what all the other units should be so that all the units in the second term are dissolved, and I can add it to the number 1. Temperature is given as 273 Kelvin. The pressure is given as 100 atmospheres. But right away, before I actually plug this into the calculator, all my numbers, I have to demonstrate, and you need to do so on the quiz as well, that all of the units are going to cancel. And so I see my volume is going to cause a problem here because I've got liters and I have essentially milliliters. So I could change this to mils and therefore change that number, or put in a conversion factor here on the denominator, but I think it's easier to just put in something else here that converts my cubic centimeters to liters. And so, and just make it part of this calculation inside, you can add square brackets if you like, inside this second term. So convert all in the same line your cubic centimeters, which is basically mils, to liters here, so then everything cancels. And you'll have to take care of it here as well. But my advice to you right now is to make sure you do this. If you do it for the first time, you are not practiced enough to do it efficiently, because everything that's coming is a bit of a surprise. So do it the long way. Instead of just watching me explain it to you and say, okay, yeah, I get that, that makes sense. Actually do this question out, because here you've got essentially milliliters squared, and down here you've got liters squared. So I want to make sure you know how to take care of those units as well, so that they are the same, able to cancel, and so on. Okay, so once we do that and get our numbers in and our units all jiving, then a negative 0.09686 is too many sig figs, but anyway, I'm still carrying numbers here. This is my value for the second term, so essentially what's in the circle here and what I've expanded here. That's what you should get here. And my third term, it should come out to 0.02391. And again, they don't have any units because they all canceled. And just slide this up a little bit more. So then my value for Z is 1 plus my negative 0.09686 plus the 0.02391. And that comes out, now I'm going to trim it back to 3 sig figs, 0.927. That is the value of my compression factor. And if I were asked to make a comment on whether the repulsive or attractive forces are dominating, in this instance, I would conclude that it is the attractive forces, and that's because my Z is less than 1. So my compression factor less than 1, easily compressed gas under these conditions. The final part of that question asked you then to use that Z value to estimate the molar volume. And so that's what we've done. Right here. Let's not look at this for the moment. But we've got back to our old standard, PVM over RT is equal to Z. And now I'm not using the virial type equation because I have a value for Z. That's 0.927. I've asked to find the molar volume. It is my only unknown in this equation. Again, my pressure is 100 atmosphere. The R is given always on a test or quiz or exam situation, 0.08206 liter atmosphere per mole Kelvin, and my temperature is 273 Kelvin. My only unknown is VM. I've rearranged it here. Z times RT over P. And so don't do this again. I'm showing you the short form. What I want to be able to give you full marks for is all of the units. I pause here because there's no units on Z, but I want to see all your units here and all the units reducing down to proving that the answer is in liters per mole. Okay. And just remember that my ratio of the real molar volume to that predicted by the perfect gas equation is also equal to Z, although I didn't have to use that here in this question. Okay, so make sure you do this question out, try it on your own, and then go through the video and make sure that your numbers are working with mine. And you know, if you're off, if you get 0.207 or 0.209, we've just carried things differently up here. I wouldn't worry about that. But the most important thing in all of this is units. Okay, the unit conversion and the unit cancellation, and I can't stress that enough. Okay, great.